Today I'm going to be talking about D-sub connectors, but probably not the type you're used to. As I mentioned on a previous episode, I have been doing some work on upgrading the electronics in an aircraft, otherwise known as avionics. One of the things that you find quite often are these deep sub connectors. They're not quite the same as the other D-sub connectors. These are two different entities because I guess they follow mil-spec. I'm not really sure of the difference, but they use a different type of connector. They're not soldered on, they're crimped on, and they're actually pretty cool. These connectors are a little bit more expensive than the really cheap crimp-on ones, but they're designed to be very reliable and last for a long time. So let me take you to the bench and show you what I've been working on. I've been doing some work on avionics, and this is an example of one of the things I'm working on. This has some pins in it that are machine pins, and you'll see what that means in a minute. But one of the challenges is to sometimes get these out to either fix an issue or to change the wiring. And this is a standard tool that I purchased to be able to get the wires out or to put them in. So the red end is for extraction and the white end is for insertion. The difference is that this will push against the barrel, where this will go around the barrel and hopefully release the latch. Now, one of the problems that I was having is that I was spending a lot of time basically push it in and I could not get it to release. And I just tried and I tried and I tried. And then asked the mechanic to show me how to do it, and he tried and couldn't get it to do it. And then he had another tool that he used, was able to get one pin out, but then the tool broke. So I decided to do some research to see if there's a better tool for this. And in my research, I discovered this tool here, which is, you can see the number here, and I'll try to put a link down below. It has a stainless steel end on the piece, and it sounded like it would be a lot stronger, and it wasn't that expensive, and I was hoping that it would work better. And it does, which I will demonstrate here. So basically the way you're supposed to do it, and it doesn't always work the first time, but it does work, is you push it in all the way and then you rotate it 90 degrees. And then you can pull on the wire and the tool, and out comes the barrel. Now, when I mentioned that this is a machine barrel, let me zoom in a little bit and you'll see what I mean by a machine barrel. This is an example of a machined barrel. It's machined because you can see it has a clean outside diameter and then it has an inside diameter, and this is where the wire goes in. And I'll show you next what that looks like when it's been crimped. Now I'm calling it a pin, but this is actually the female version, and there's also a male version of this that is for the other side. This is what it looks like when it's been crimped, and you can see that there are some marks, basically depressions on all four sides. This is what provides the electrical connection as well as the physical connection. And you can see it's important that the insulation does not go underneath where the crimps are, because that can interfere with the electrical connection. There is also a hole in here, which is right there. And that hole is to make sure that you have the wire going all the way in before you crimp it. So that can help you strip the wire to the correct length. The next step is to get the pin into the connector. If the wire is, and the insulation is thick enough, it's pretty easy. What I do is I put this in and then I wiggle it around a little bit and it moves in quite easily. And then I just want to choke up on the wire and push it in. Sometimes it can be a little bit fiddly, there it goes, until it snaps into place, and now it's firmly in place. Smaller wires are also the same thing. I push it in like this and again choke up on it, and there we go, it snaps into place. Now this tool has an end here that's supposed to allow you to insert the pin, but I've found this very difficult to use and it doesn't work most of the time, so I've pretty much given up on this. The idea is where it's thick right here, this is where you insert the wire, the insulation. you push it down in there and then you kind of slide it this way, which I can show you here. So what I need to do is try to push it into the slot here, get it engaged, and then I'm sliding it over until it fully engages like this. Now the problem I have is you can see how this is splayed out a little bit. And what happens is that that typically ends up going over like this, and then it interferes with pushing this into the connector. But I'll give it a try anyway. So here you can see I have it out far enough. So actually it did go in, and then if I push, it's now pushed in all the way, and actually it worked this time. But as I say, it doesn't always work. And that's kind of how you need to use this, though. As I said, it is a little bit finicky. And so most of the time I just insert it by hand. This end, I never really get to work. So I mostly don't use this tool. Instead, as I mentioned, I use this tool for extraction. If someone knows of a tool that is also really good for inserting, that is, of the quality of this tool, please put a comment below because I'd love to learn about such a tool. The sockets and pins that I have been using came with the kits for the avionics that I've been working on. You can also buy extra parts. Here's a company, Steinair, that sells a lot of products to people building their own airplanes. They have both the socket, as you can see here, as well as the pin. Now the difference between them is you can see this has orange, blue, and then gray as the color codes. This one has orange, blue, and white as the color codes. I was trying to figure out what is the difference between the color codes. So I did some searching and found information on DigiKey. DigiKey also sells them, and their price for 25 is slightly less than Steinair, but pretty close. You can see that this is orange, blue, and gray instead of white. But I did find this datasheet listed here. And if we look at the datasheet, you can see that it has orange, blue, and white for the pin, and orange, blue, and gray for the socket, which is consistent with what I had. The other thing is, these are standard density connectors. They also make high density connectors, which I'll talk about in a little bit. This is the tool that I use to install the pins. The pin goes in here, and then this has a ratcheting feature that basically has a set of jaws that come in from four sides and create the indentations. Now, if you push this in part way, it does not snap back. You have to push it in all the way before it'll snap back, and that's how you ensure that you do a complete crimp. I also briefly mentioned that there are standard density connectors. This is a high density connector. So the difference between these is these pins are a little bit smaller, and that allows you to have them closer together as well as to have 3 rows in about the same space as 2 rows there. Here I have a pin in the socket. The pin is the high density pin, and the socket is a standard density socket. You can see the difference in diameter between those. And so what that means is that I cannot use the same extraction tool for the high density that I use for the standard density. It also means you can't use the crimping tool, at least the way that I got it, for the high density. If we look at the back side of this tool, you can see that there is this piece here that has some knurling on it. It has knurling because you can unscrew this, and I'm not going to unscrew it all the way, and then replace a piece inside that allows you to switch from standard density to high density pins and sockets. So if you replace this with that other part, then you can crimp the high density connectors. So I'll put a link below to the part that allows you to work with the high density connectors, and again, it's not that expensive. This episode I made because it's something I wanted to watch. There are lots of things that I put in here that I didn't know when I started, and it certainly would have made things easier if I knew all of what I have in this video when I started. And so that's why I made it, to hopefully help someone else through this journey and make it a little bit easier. Thanks for watching. Please subscribe, give me a thumbs up, comment below, and I'll see you next time.